Good afternoon viewers and welcome to the Science Stream EduSet lecture. Today we have with us Dr. U.S. Pandey, who has been with us for the computer science stream. He is an associate professor at the School of Open Learning at University of Delhi, and today we will be starting another series of lecture in computer science, and the lecture today is about grid computing. So over to Dr. U.S. Pandey.
Thank you. Let's talk about the grid computing, which is the latest area, especially in the computer science. So just try to get what do you mean by a grid. As you already know, grid is a kind of thing you have listened about the power grid or so many other activities, putting a best utilization of biggest computer activities together. Now, how do you are going to define a grid computing? Using geographically distributed and interconnected computers together for computing and for resource sharing. That is going to be basically a grid computing environment where you do have a lot of biggest computers, putting them together and try to utilize all the infrastructure. The grid. Common practice to use word grid as a proper noun such that G is capitalized, although does not refer to one universe grid. There are many grid infrastructures. We have set up one for this course also. You will learn how that was done and the technicalities in the course. Need to hasten the computers. Original driving force behind grid computing, same as behind the early development of networks that become the internet, connecting computers at distributed sites for high performance computing. However, grid computing is about collaborative and resource sharing as much as it is about performance of computing. We would like to tell you that grid computing basic objectivity is that collaborating a lot of resource sharing are especially for high computing activity. Imagine a biggest problem is there. To resolve that, sometimes you may require many computers. Much more resources are going to be required to compute that thing. So, utilizing those biggest resources, maybe in parallel form, maybe in other activities, utilizing all those resources, putting them together, utilizing all these activities togetherness, maybe parallelly or in other activities. So, getting a high performance computing, we need this grid computing, which is going to be utilized in many areas, not only in computers, applicable in different areas of the practical problems. Virtual organizations. Grid computing offers potential of virtual organizations, group of peoples, both geographically and organizationally distributed, working together on a problem, sharing computers and other resources such as databases and experimental equipment. As I have just mentioned, just to resolve a typical problem, a complicated kind of problem, it could be that the nature of problem is not going to be resolved at one particular places. It could be that the problems are arising from different parts of the country, different parts of the different places. Take example, if you are going for a research work which is not only at one place, different laboratories, those resources or the different scientists have been put together to discuss lot of things, accessing the database and utilizing all experimental equipments can be put together. Different organizations can supply resources and personnel. Concepts has many benefits, including problems that could not be solved previously for human or in convey humanity because of the limited computing resources can now be tackled. As I have just discussed, the major achievement or the major activity of utilizing this gate computing is the problems which are very complicated in nature, as we are just saying, which cannot be easily resolved by the human being, or you can say that the problem cannot be solved using few computers, can be solved using grid computing techniques. One way, utilizing the different resources, different computing environment, putting them together and utilizing all of the resources in a best way. Examples. Now you understanding the human genome. You may be already knowing that understanding the human genome is not a simple problem. A lot of complicated designing of this genome, the genomics, understanding the structure, the calculation of each and every genome, understanding about the genome, it is not by a simple computer. So, just to resolve those kind of activity, you required a different environment, and that environment can be tackled by using grid computing. Imagine, based on the structure of the genome, based on the structure of the different disease and activities, you can search for a new drug. There are many problems which have been tackled by utilizing this kind of activity, the grid computing, and things have been resolved, different new drugs have been searched, which is the best suitable in that. Imagine if you are able to understand the genome structure of a particular the problem, and you are able to think that what kind of drugs can be best suitable for that structure, or in other words, which is going to be the best structure to resolve that. Another thing, how that things can be resolved by utilizing another complicated structure. Say, for example, already you know, just to tackle the problem like cancer or the problem like some special diseases which cannot be easily met, by utilizing the different grid computing techniques, we can understand the different patterns, the different techniques, the structure, and if possible in the reverse way we can develop the different drugs which is going to be the best suitable for them. Just to tackle all those kind of activities, a simple computer cannot perform activity. So, we definitely required a lot of resources to handle all those things. Putting lot of resources together, not only in the form of hardware, in the form of other activities, maybe in the form of different scientists putting the ideas, utilizing those things, developing a different computing environment. In other words, it is going to be a complicated environment where many computers may require in a huge form. As you have understood, you may be knowing about the Power Grid Corporation. The job is the distributing the power, collecting the power and providing each and everything. It is a big job in that area. Same way the grid world you can see here also, the object is to put a lot of resources together in a collaborative way and to provide you the best solution possible. User can have access to far greater computing resources and expertise that available locally. The best use of grid computing, as we have just mentioned, to utilize the best resources available, the best manpower available, the best techniques available, and imagine putting all of them together using the different latest technologies. As we have just mentioned, every day a new concept, new things are coming into the grid computing, where these kind of resources can be utilized in a much more good way. So, here are the best examples are going to be there. Interdisciplinary teams can be formed across different institutions and organizations to tackle problems that require expertise of multiple disciplines. Again, I am taking the example of the same, where a bioinformatics is there, biotechnology is there, biocomputing is there. You understand, sometimes a computer scientist who is not having the knowledge of other areas cannot do the exact thing what is required. In the same way, a biology person who is understanding a biology in much good way, but he is not expert in mathematics or in computing that environment, may not be the best suitable for that job. In other way, a medicine doctor who has understand the proper disease in detail, but still he is not able to compute the things properly, or he may not be able to use the pattern recognition to understand the things and all. What I mean to say, the persons belonging to the different system can be put together, can share lot of things, and then any problem, it may be related to medically or any complicated kind of problems, can be used by the grid computer, resolved very easily. A lot of resources, again I am going to say, put together, and that problem you can achieve the goal. Specialized, localized, experimental equipment can be accessed remotely and collectively. As we have just mentioned, the main objective is that the different specialized personalities of the different area, if required, can be put there, their ideas can be shared, and the different equipment who are expert in this particular area can be put together, and the best utilization, putting all of them together, can get a proper goal and objective. Large collective database can be created to hold vast amount of data. Unused compute cycles can be harnessed and remote site, achieving more efficient use of computers. Business processes can be re-implemented using grid technology for dramatic cost saving. As we have just mentioned, grid computing does not mean only to doing the computing job. A large collective databases which have been there for different purpose at different places can do a better thing when you do the proper utilization of those data. As we have just discussed, if the data is at different sites, at different places, those data can also be utilized from a proper meaningful activity. Or in other words, take example, some of time the remote data activities can be put for the research activity at many good laboratories. By using this technique, a huge amount of data can be computed easily. And as we have just mentioned, especially in the area of medical science, in the area of calculation of different databases or the high performance computing, these kind of activity can be used. Again, in the business processes also, the re-implemented using great technology is going to be there. Cross multiple administrative domains, as we have just mentioned, using grid computing techniques, lot of activities can be done. Another hallmark of larger grid computing projects, resources being shared, owned either by members of virtual organization or donated by others. So, here different kind of multiple administrative domains can also be there. Now, introduces challenging technical and social political challenges also. It requires two collaboration. As we have just mentioned, the basic objective of the grid computing that the major resources can be put together and their collaborative utilization can be done easily. In other way, to achieve a proper goal, this grid computing is playing a very important role. It could be a socio-political challenges, it could be any other areas, it could be in the area of BPOs, it could be in the different area of life. Some key features we regard as indicative of grid computing: shared multi-owner computing resources, uses grid computing software with security and cross management mechanism in place, tools to bring together geographically distributed computers owned by others. As we have just mentioned, the computing resources can be put together. It could be by utilizing the different means, especially the utilizing the grid computing software with the security and the cross management mechanism. Because when we have to utilize the different resources, then the security is another biggest problem. So, taking care of all those things, these resources can be put together and things can be utilized in a much better way. Shared resources can share much more than just a computers. Here, storage, which is again the biggest problem. Sometimes you do have a lot of information, as already you are knowing. This information can be stored at a different computers, different places. If required, all of them can be put together and then they can be utilized. Sensors for experiments at particular site. Utilizing this grid computing technique, these things can be shared. If you are doing some activity at a different remote areas at a particular site, these things can be shared. Utilizing this grid computing, the application software, databases, network capacity, each and everything can be shared. By sharing all these things, it is not that you require the all equipment each and every places. The whole database can be accessed from any remote area. The computing can be done at any places. Not only computing, it could be high computing, high performance can be achieved utilizing that. So, especially it could be in any area, these kind of resources can be shared for a specific purpose. Interconnection and protocols, as we have just mentioned, after utilizing in this grid computing environment area, the security and other problems is going to be there. So, focus now on using standard internet protocols and technology such that already you know HTTP, SOAP, web services, etc. History of distributed computing. Certainly, one can go back a long way to trace the history of distributed computing. Types of distributed computing exist in 1960s. Many people interested in connecting computers together for high performance computing. Now, you can see this high performance computing, the distributed computing, it have an history of that from connecting processors, computers together locally, that began in earnest in 1960s and 1970s. Distributed computing now extends to connecting computers that are geographically distant, a grid computing. As already we have just mentioned, the different resources, different centers for doing the computing, different equipments which are being utilized in the area of distributed computing, putting all them together which have in different places could be utilizing this grid computing environment. Distributed computing technologies that underpin grid computing developed concurrently and rely upon each other. Three concurrent interrelated paths. One is networks, the computing platform, the software techniques, and the different, now just starting with the different way how the networks are going to be there. The network developed in a packed switch network. In 1969, a ARPANET network became operational. 4 nodes. University of California at Los Angeles, Stanford Research Institute, University of California at Santa Barbara and University of Design, speed of 50 kilobits per second. Now in 1974, in the work of networks, you are already knowing TCP, Transmission Control Protocol came. And then 1978, TCP IP, Transmission Control Protocol, which is going to be known as Internet Protocol in that way. TCP, a protocol for reliable communication. IP, Internet Protocol for network routing. IP addresses identify hosts on the internet ports, identify and points, that is processes for communication purposes. So, these are the two developments in the area of networks. Now, in early 70s, Ethernet for interconnecting computers on the network. Already you may be aware that in 90s when internet had come, uses the TCP IP protocol. In 90s, internet developed into World Wide Web that we call WWW. Browser and HTML markup language introduced. HTML stands for hypertext markup language, as you are fully aware. These things have been developed in 90s. And then computing platform, these were the development in the area of networks. As we have say that another area which was the computing platform. So, little bit historical background of the computing platforms, where in 1960s recognized that increased speed could potentially be obtained by having more than one processor inside a single computer system. Parallel computers coined to describe such system. In 1970s and 80s, many parallel computer projects, especially with advent of low cost microprocessors. And in 1990s, as already you know, in the computing performance, a lot of big things have come. For example, you may be knowing earlier very small computers which were there, which can compute things up to a limited activity. But now imagine today, even your mobile phones are much more powerful than the biggest computer which was available at that time. So, technological change had entirely. It was the different computing platforms which have been developed till now, utilizing the best technology. Earlier, to compute a much more high performance activity, you require many parallel computers to put together, and then they resolve, or they do the parallel computing, or in other words they do the high performance computing. But even now a small laptop, a small mobile which are coming with the latest good configuration can do a lot of better computing. They provide you the better environment. So, in 90s cluster computing, a group of computers interconnected through a network switched to form a computing platform. Commodity computers provided cost effective solutions. Here you can see a typical cluster computing configuration. Now imagine the compute nodes were there, you can see downstairs. Now switches are there and interface, generally Ethernet or a different kind of node is there. So, this kind of cluster computing configuration which is being connected through internet. So, this kind of a cluster computing techniques are being used. Now, another important thing is programming clusters. As we have just discussed about the networks, about the computing platforms. Now, another very important thing is programming clusters. Message passing programming, messages between processes specified by programmer using message passing routines. In the late 90s or up to 90s, PVM, parallel virtual machines were there. In 90s, MPI, message passing interfaces were developed. Now, in this programming different cluster in 90s onward, Condor, to harness unused cycles of network computers for high performance computing. A collection of computers could be given over to remote access automatically when not being used locally. Now, this is a very important kind of activity which have been used earlier. Widely used a job scheduler for clusters in addition to its original purpose for using laboratory computers collectively. We will consider Condor in the light of grid computing. Now, imagine the objectivity of that the best resources can be utilized at each and every places. In 90s, the remote procedures call that we call RPC for invoking a procedure on a remote computer. There were the different software techniques which have been used in mid-80s. The service registry introduced with RPC, that is your remote procedure call, to locate remote services. As we have just mentioned, the resources which are available locally can be utilized easily if they are not being used or if they are not in use at the moment. So, just to utilize that services in a best way, in a better way, we can utilize these kind of techniques. You have already knowing object oriented versions of RPC, that is CORBA, Common Request Broker Architecture, Java Method Invocation RMI. So, the different software techniques being used to make the resources to best useful. Again, we are putting the same thing, objective is that the resources which are lying at different places can be put in a best use. You may be already knowing about the cloud and other aspects. So, by grid computing, a lot of resources can be put together and they can be used in a much more collaborative utilization can be done. So, as we have just mentioned, the CORBA and the RPC, the different techniques were used earlier. What is happening now when you are using in 2000 and above that? The web services provide remote action as RPC, but invoked through standard protocols and internet addressing. Use XML, that is extensible markup language, also introduced in 2000. Web services and XML adopted into grid computing soon after their introduction. As we have just mentioned, in earlier 90s and 80s, the different structures were used to utilize the resources. Now, in 2000, when web services has come into their in existence, they become the part of the grid computing technology. Or in other words, we can say the resources can be best utilized using the web services or using the different protocols. As we have just mentioned, the XML as a language which was introduced in 2000, it have been adopted into grid computing, because by this you can do the use of all activities. Now, let us share the grid computing history. Begin in mid-90s with experiments using computers at geographically dispersed sites. Seminal experiment IWay, experiment in 1995, supercomputing conference SC90 using 17 sites across US running 60 plus applications, existing networks 10 networks. Globus project. Now imagine the sum of the project which have been delivered at that by led by Ian Froster, a code developer of the iWay, which we have just discussed that iWay demonstration, and founder of the grid computing concept. Globus, a middleware software grid computing toolkit, evolved through several implementation versions, although basic structural components remained essentially same. The Globus project, the major thing about that was the security, data management, execution management, information services, runtime environment. We will discuss in detail about the Globus, the other computing middleware softwares. As we have just mentioned, in the history of the grid computing, although Globus widely adopted and the basis of the course, there are other software infrastructure projects where in 1993 the Liaison project, the software development started in 1906, used object oriented basis to the grid computing. The first public release as a supercomputing 97 in November 97 lead to Awaki company software taken over by Sybase. You may be already knowing a lot of big softwares which have come into the market after doing a lot of experimental activity. So, in 1993 that was going to be there. Other grid computing middleware software in 90s is Unicore, which is very popular, uniform interface to computing resources. European grid computing projects initially funded by German Ministry for Education and Research, continued with other European funding. Basis of several European efforts in the grid computing and elsewhere. Many similarities in these projects were similar to Globus, which we have just discussed about that. Other projects, here you can see that the key concept in the history of computing. Imagine you just started with the different IP addresses, protocols, networks, markup language, it could be HTML and all, remote procedure and different calls, beginning of services oriented architecture, coming to the web services, adopted for grid infrastructure components. You can see here the geographically distributed resources, how these Unicore, Globus toolkit, grid computing applications, computing platform, software techniques as we have just discussed, networks and the application which is on demand utility computing, and in the last going up to cloud computing. So, imagine the total complicated structure, how the things have changed from starting in 90s up to 2010 or beyond that. Things are coming very fast in high performance computing, or you can think that you can utilize in cloud computing environment. Here on demand the different kind of utility can be done, the business computing can be done, the high performance collaborative scientific computing can be done. So, different kind of concepts have been developed in the history of grid. Some of the applications originally e-science application, computational intensive traditional high performance computing addressing large problems. Not necessarily one big problem, but a problem that has to be solved repeatedly with different parameters. So, lot of different applications of the grid computing is going to be there. Another is data intensive, computational, but the emphasis on large amounts of data to store and process. Experimental collaborative projects are also going to be there. Now, also e-business applications are going to be there to improve business models and practices, sharing corporate computing resources and databases, on demand grid computing indirectly lead to cloud computing. Imagine we have just mentioned that utilizing all the resources, this grid computing lead to the cloud computers. We do have a lot of good lectures earlier also about the cloud computing resources. Now, just see how the grid computing is going to be utilized using those cloud resources. The high performance computing and high performance activity, utilization of the best resources at any places can be put together and you can use it in that way. One more, how the cloud computing using virtualized resources, you can see here the different cloud, the servers which have been put, the virtualized resources, and as we have just discussed earlier also, paying users geographically distributed. We do have given earlier also an example. You can simply take, if you are a citizen of Delhi in India, you can use the site of Indian government for any purpose, for any utilization. It could be just to collect your birth certificate, it could be collecting any kind of your ration card, it could be a collection of any other services which is offered by the government to you as a citizen from any place. If required, just by paying a single penny, you can utilize the best resources of the government and you can do things much more in a good way. What do you mean by that? You need not to visit the office of the government. You need not to go to every corner just to pay a bill. Simply, you can utilize these cloud services which have the background in that grid computing environment, different complicated structure. Imagine instead of having different municipal corporation offices in the entire part of the city, if you are able to collect or the delivered or you can get the each and every information just by one place. It may be that the services are paid. By paying nominal amount, you can access all the services. You need not to visit the office for that particular, for getting any specific. As already you are knowing, Aadhaar card or unique ID, which is coming as the biggest thing to you, which will provide you the all information. It is very easy to for a common man that to get and that card number. Imagine to maintain that huge data, processing that, accessing those information, putting them in a proper secure form, utilization of those databases in a best way by the companies or the organizational requirement, or only those authorized persons can access the information who are authorized to access. Imagine, it's very easy to say, but maintaining all those databases, that too in providing proper security, that too providing proper facility is not an easy job. Another thing, that you can access that same information from any part of the world easily. You can communicate easily with the entire part, not only utilizing these services, different kind of complicated structures which have been developed. So, utilizing by the different grid computing environment, you can do a lot. As we have just mentioned, lot of resources can be easily accessed. Those resources can be utilized for doing the high performance computing, which is the requirement of today. Just imagine, a Mausam Vibhag is predicting about the weather forecasting. It may look to you very easy, but doing computing, getting information from satellites and do a high performance computing, after that doing a better prediction is also a very example of doing a better computing. Because only when you able to compute the things in a proper way, only then a kind of right predictions can be done. So, these are the few examples where this computing environment can be used in the biggest way, how it will leading to the cloud computing and virtual resource utilization. Few things is that the common thread between the grid computing and cloud computing is the use of internet to access resources. That is very important to understand, that the cloud computing driven by widespread access that internet provides and internet technologies. However, cloud computing quite distinct from original purpose of grid computing. As we have just mentioned earlier, the grid computing, the objective was to put lot of computing environment in a collaborative form, and that can be utilized for doing the how this good performance. You can see the grid computing versus cloud computing. Whereas the grid computing focuses on collaborative and distributed shares of resources, the cloud computing concentrate upon placing services for users to pay to use. Technology for cloud computing emphasizes use of software as a service. We have already discussed about the SaaS and other things, and the virtualization, the process of separating particular users' software environment from underlying hardware. Different kind of Arne Foster checklist. The Arne Foster credited for development of grid computing, which I have discussed earlier, sometimes called father of grid computing. The proposed simple checklist of the aspects that are common to most true grids: no centralized control, standard open protocols, non-trivial quality of services, and all that we have discussed today about the grid computing environment, something about the networks, brief history of the grid computing environment, and we have tried to compare how the cloud computing is different from the grid computer environment, how the grid computing is going to be utilized in the best way, in a collaborative way, and what is going to be the much more impact to do the high performance or how computing environment. So, that is going to be the for today. Thank you.
I would like to thank sir for a very informative lecture. Definitely sir, these are very confusing terms, grid, the cloud, and with your lecture many of my queries have been answered. It is not surprising that a lot of research depends on large databases and high performance computing, and how we can use the unused computational networks for achieving scientific, medicinal, research in climate, forecasting and monitoring and businesses, and they cannot sustain without the grid computing. Also, he notes a word of caution regarding the security threat and the protocols to be in place for utilizing the grid computer. I would like to thank Sir, and we will of course wish the users, the viewers to join with us for the series of lectures with Dr. U.S. Pandey. If you have any queries or questions, you are more than welcome to write to us on the email addresses provided, and this lecture will be uploaded shortly on the YouTube for your reference. Thank you, viewers.